Good evening, students. Today we are going to learn about how to design the flowcharts for object-oriented concepts. So, one of such concept is inheritance. So, where it promotes the code reusability, where you will have one class is call it as a parent class, the another class you can call it as a child class or the subclass. So with the help of this concept, a child can acquire the properties of the parent. A child can acquire the properties of what? Parent. Now whatever the properties and the methods are there in the parent class, once the inheritance relationship is established between the super and sub or parent and child, the child can acquire the properties of the parent. So let us see the same, let us realize the same with the help of the flowchart, right? So first you have to convert this into object oriented mode. Yeah, object oriented mode is selected. Now what I am going to do is I am going to shift to UML tab, then I am going to add a class. I'm going to add a what? Class. So here the class the class name I'm going to make it as shape. So the class name is what? Shape. Now this shape will consist of a couple of methods. Let us say the first one is area method. Area method. So under this shape we have added one method. What is that method? Area method. Now from this shape class I can derive the one new class. Yeah, one new class. Let us say the class name I'm going to change it as 2D. Yeah, let's say two-dimensional shape. So I have deriving one more new class is called two-dimensional shape. So let me derive the one more class also from this, and I'm going to make it as what? Three-dimension shape. Three-dimension shape. So right, let me have this. Right now there is a class called area shape. So under the shape we have only one method, that is what? Area. Now from this shape I have derived two new classes, that is what? Two-dimensional shape and three-dimensional shape. So for the shape we have the two childs. Now see, yeah, and one more has been derived, that is what? Right, right. Now so let me reduce the size here. Yeah, right. From the shape I have derived the two new classes. One is two-dimensional shape, the another is the what? Three-dimensional shape. Now for this two-dimensional shape, what I can do is, so I'm going to derive some new classes for this two-dimensional shape. So let me name it as square, and let me have one more class. uh, Let me make it as rectangle. So these are the two new classes I have derived from the what, two-dimensional shape. So let me establish the relationship between these two. Done. And one more class is also derived from this two-dimensional shape, that is what, yes, rectangle. So from this three-dimensional shape, what I am going to do is I'm going to add one more new class, that is called cube, and one more shape I am going to add. So this is what is called cuboid, right? These are the what, three-dimensional shapes. Now this cube is derived from the what, three-dimensional shape. Yeah, right. Now and this cuboid is also derived from three-dimensional shape only. Right. Sorry. Okay. 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 Now here, let me have the connection. Right. Oh, let me add this ones. Right. Now see, from shape we have derived two new classes. One is two-dimensional shape, the another is the three-dimensional shape. From the two-dimensional shape I have derived two more classes. One is square, the another is rectangle. From the three-dimensional shape I have the what, cube and cuboid. Now here I'm going to add one method. Generally for three-dimensional shape we will have a behavior called volume. So that volume I'm adding here, right? So whatever this area is there, this area method can be available for the child classes, available for the child classes. Now what I am going to do is, this two-dimensional shape will also have the what, area method, right? So that area method, it is going to override from the what, shape. So let me add it. Okay, done. Similarly, this three-dimensional shape is also can override the what? Area method. Done. Then here also we will do the same. And here also we will do the same. Right. And in cube also we will have the what? Area. Right. So since it is having area and volume, both can be overridden. Done. Now here the same area and volume both can be overridden here also. Done. Now, so what is the property can have by square? Square will have the property called what? Side property. So that side I have added. Now rectangle will have the what? Rectangle will have the length and breadth. So let me add those length, and one more we have, that is what? Breadth. So add one more property, breadth. Now cube generally have what? Cube can have what? Side. Yeah, let me add the property side. Then cuboid will have the properties called what? Length, breadth, height. Length, length, and this is what? Breadth, right? Breadth. And let me add one more, height. Done. So we have added all the properties here. Now what we have to do is we have to provide the definitions for one by one. So first go to the shape. So under the shape we have the what? Area. Here I am going to write some code here. So the code I am going to write here is, just I am going to edit shape area depends on type of shape. So this is what the message I have configured here. Now shape is over. Then I will shift to two-dimensional shape. Under the two-dimensional shape again I am having the area. So here I am going to write area formula. Area formula depends on type of two-dimensional shape. Type of two-dimensional shape. This is also over. Now three dimension. So for the three dimension again what I am having the volume and area. Again for the volume, so what I am going to write here is volume is depends on type of 3D shape, right? And similarly for area also, shape to shape it is going to be differ, right? So here also what I am going to do is area depends on 3D type of 3D shape. Type of 3D shape. Done. Now coming to the square. So what is the formula for this square? The formula is what? Already it is having the what side property. The formula is a square, right? Self dot side into, sorry, not self here, this dot side into this dot side. So this is what the area for the square. Now rectangle. So for the rectangle, what will be the formula? Now edit this dot length into this dot breadth. So this will give the what? Area of rectangle. Now coming to the cube. Cube will have the what? Volume. First volume. So volume of the cube is what? A cube, right? Then again written edit this dot side into this dot side into this dot side. So this will give the what? Volume of the cube. Now area of the cube. Area of the cube is what? 4a square. So again written edit 4 into this dot side this dot side. So this will give the what? Area of the cube. So these are all. Now I am shifting to the what? Cuboid. Now cuboid, what will be the volume of the cuboid? Length into breadth into height. So this dot length into this dot breadth into this dot height. This will give the what? The volume of the cuboid. Now area. So the area formula is 2h into L plus B. Written, then edit 2 into this dot height into this dot length plus this dot breadth. This dot breadth. So now I have provided the definitions for the what? Almost all the things. Now let me go to my main tab. Now here I can create the object for one by one class, and then I can call the respective methods. First let me create the object for the what? Shape. S1 equal to new shape. So object is being created. Then after I can call the what? I can call the method. What is that method? S1 dot area. Done. So over. Then after I can create the object for the what? Two-dimensional shape. Then let us create the object for the two-dimensional shape. Insert assignment symbol. Then S2 equal to new two-dimensional shape. I have created the object for the what? Two-dimensional shape. Now I am going to call the method. Insert call S2 dot area. S2 dot area. Now likewise I can create the object for the what? Three dimensions. Let us create the object for the three dimensional shape. Insert assignment. Let us edit the symbol. S3 equal to new three dimensional shape. So object has been created. Now what we have to do? We have to call the method. So again insert call edit S3 dot area. Right, we have done this. Then after what we have to do? We have to create the object for the what? Square. So insert assignment edit S4 equal to new square. Object has been created, right? Then So what we have to do, we have to assign the side value. Side value, how we can assign? Yeah, object has been created, right? S4 dot side equal to some 10. So I am assigning the side as a what? 10. Then after I can call the what? Method, right? That area method, right? Okay, then what I am going to do is insert output. Here I am going to call that method s4 dot area. S4 dot area. So likewise you can also do it for the cube and cuboid. Let us execute this. Let us see how exactly it is going to behave. So you can see stepwise the execution, how exactly it is going to execute the each line. Yeah, keep an eye on this watch window so that you can see what are all the variables are there in this program and how their values is getting changed. Okay, right. Now since we have square area, that is what 100 has been printed. Now if you want to go for the rectangle also, so first create the object for the rectangle. Edit s5 equal to new rectangle. Then what we have to do, we have to assign the values for the length and breadth, right? Then insert assignment, edit s5 dot length equal to 100. Then we have to assign the breadth also, right? Then so let me have the one more assignment, insert assignment s5 dot breadth equal to some 20. Now what I want to do, I want to print the area of the rectangle. So insert output, edit s5 dot area. S5 dot what? Area, right? So let me execute the same again. You can see here how exactly the each statement is executing, how the control is moving from one program to another program. So at any point of time you can see the watch window status. It will show what are all the variables are there. Yeah, 2000 has been printed. So similarly you can continue for the cube also. So let us you try for the cube and cuboid. Cube and cuboid.